A recent study sought to find if any correlation existed between childhood weights and self-esteem. Children between the ages of 9 and 11 were surveyed, and it says children, so this time we have boys and girls for our data. Weight was measured in pounds, and self-esteem was measured based on the average of the answers to 15 questions, asking the participants to rate themselves on a scale of 1 to 5, where higher scores indicated higher self-esteem. That's the important takeaway from that sentence. Here's the data for 12 cases. So we have weights and we have self-esteem scores. First thing we want to do is find R and see if it's statistically significant at two different levels. One is the 0.05 level and the other is the 0.01 level. I highly recommend that you go ahead and try that one and then play the video to see how you did. Starting with my calculator, I know I need to enter this data so I can find the R value. So I first want to clear my data. So I'll do second data, slide over to clear data, and push equals. Second data one more time, and it is on the 2 variable. That's good because I have 2 columns in my table. And then push data, and we'll start entering data. 54.3 for the X goes with 2.6 for the Y. Come to your table and mark that one off. 62 for the X, I don't have to put the 0.0, and 4.6 for the Y. Mark it off and continue on until all your data is entered. After I put all of these values in and I double checked that my N was the correct size and that I sort of went through and looked at all my numbers to make sure that they looked correct, yeah, I do have a 1.0 in there. Anything that looks weird, I just go back at the data and look on that row and see if it's correct. And it looks like I have these correct. So now I can push stat var, and it shows my N is 12, and go to the left, 2, 3, and I have my R. And this R value is negative 0.605. And we'll put a 1 because the following digit is a 6, so we'll just round it. And what I want to do is look to see if R is statistically significant at the 0.05 level. So I'm looking at alpha equals 0.05, and I'm also looking at N equals 12 because there are 12 data pairs. And so I'll go back a page or two and find my table. I'm just going to copy this for 12, so the N is 12. I'll copy that row. Put my data there. This is the N, and this is for alpha equals 0.05 and for alpha equals 0.01. For alpha equals 0.05, we can see by comparing that we definitely are greater than or equal. Remember, we look at the absolute value of R, so we're going to just ignore this negative sign and look at it as 0.605, which is definitely greater than 0.576. But it is not significant at the 0.01 level because we are not at 0.7 anything. So we are significant at the 0.05, but not at the 0.01. R is statistically significant at the 0.05 level, but not at the 0.01 level of significance. Write down the linear equation in the form y hat equals mx plus b. I can look on here for the a, which I need to write down first, and it's negative 0.084182. 1, 2, 3, 4, 5, 6. We'll do 6 digits, and then put my X, and then let's see what the B is. it's going to be plus 8.721938, but I'll change it to a 9 because the next digit is a 9, 5 or greater. Okay, and then also remember, anytime you write down the linear equation for the regression line, make sure you write down what does the x stand for. And in this case, this is the weight. And I'm wondering, pounds. So I'll put weight in pounds. And then the y hat, the thing that we can predict with this equation, is going to be the self-esteem score. So this is a complete description of the linear equation. Write it out, write what x stands for and what y hat stands for. If appropriate, predict the value for the level of self-esteem given that a 9-year-old girl weighs 45 pounds. Well, it says if appropriate, and that's trying to warn me that maybe I'm not going to be able to make a prediction, but let's check. We have a 9-year-old girl, and if we come up here, we did say between the ages of 9 and 11, that's fine, and it did say children, so it's girls and boys, so we're fine. And then 45 pounds, so let's look in the weight column, and I don't see anything as small as 45. The smallest I see is the 54.3, so that's telling me that I can't make a prediction for this girl because her weight is too low. We can't predict a self-esteem score for this girl because her weight is outside the weights for the data set. So if she's lighter, which she happens to be, or heavier than the data set values, we can't make a prediction for her. And in her case, she's too light, so we can't predict. And the reason is if she's underweight, she might have a higher, lower self-esteem just because she's so much skinnier than the other children. But we don't know because we don't have any data for those children, so we can't make a prediction. It would predict her to have a really high self-esteem, but that may not be the case because of her being underweight. If appropriate, predict the value for the level of self-esteem given that a 10-year-old child weighs 64.1 pounds. Okay, child we know is fine because it's boys and girls. Let's look at 10 years old, and we're talking about 9 to 11-year-olds. That's good. That'll work. And then the weight is 64.1 pounds. That's greater than our smallest weight, and I see some weights heavier, so we should be able to predict for this child. So we can make a prediction, and it'll be y hat equals 0.084182 times the 64.1 pounds plus the 8.721939. I'm going to show you a nice quick way to calculate. I can start off by finding my A. I'm on the B, so I'll go back to the A and just say times, and it shows me A times, and then I type in the weight, 64.1, and then I want to add whatever the B is, whether it's positive or negative. I'll just put a plus here, and the calculator will take care of it. And then I need to go back into StatVar and scroll over to the B. There it is, and push equals. Now it shows A times my 64.1 plus B. I can do enter, and it gives me a y hat of 3.32. We'll round it to 3 decimal places, so it's 0.326. Now I want to show you, if you don't want to use these variables like I'm showing you here, you can just put in the data and 0.08. Oh, of course it helps if you put the negatives down. So that is a negative, so clear. So I have to do this negative button here, negative 0.084182 times the 64.1 equals, and then I need to add, and it is positive, so I'll just say plus 8.721939 equals, and I get 3.32 326 if I round, which equals what I got from the calculator exactly. Now I do want you to know, if you want to round this to 3 decimal places, you better have rounded this one to 5 or more decimal places, and we did to 6. So just put at least 2 more decimal places than where you want to round at the end, so that your values come out exact. A 10-year-old child weighing 64.1 pounds should have about a 3.326 self-esteem score. Number 5, if appropriate, predict the value for the level of self-esteem given that a 13-year-old boy weighs 88 pounds. Boy is fine because it's for children, either gender, and 13, that's a problem because that's outside the interval of the ages that were used. So this 13-year-old boy comes from a different population than the children who were surveyed. And that's a problem because we don't know that 13-year-olds look at their bodies in the same way as 9 to 11-year-olds. In fact, I'm pretty sure they don't, because 13 is when children start to hit puberty. Things really start to change, and they could have like crazy negative self-esteem even though their weight is perfectly normal. But that's a 13-year-old thing. 9 to 11, different issue. Weight might be the only thing that makes them feel self-conscious. So we can't cross over from a 13-year-old boy and use information from 9 to 11-year-olds to predict his self-esteem. Different population, remember that was one of the big no-nos. So we'll have to say something like that for our answer. A 13-year-old is not in the same population as the 9 to 11-year-olds surveyed. We can't make a prediction for him.